Unveiling the Wonders of Time Dilation. Understanding the concept of time dilation provides a fascinating insight into the nature of our universe. Time dilation is a difference in the elapsed time as measured by two observers, owing to a relative velocity between them or to a difference in their gravitational potentials. It's a fundamental aspect of Einstein's theory of relativity, which revolutionized our understanding of time, space, and gravity. Einstein's theory of relativity serves as the foundation of time dilation. The theory, published in 1905, introduced groundbreaking concepts about the fabric of our reality. One of these is the concept of space-time, a four-dimensional framework combining three dimensions of space and one of time. In this framework, time can stretch or shrink depending on the relative motion or gravity, leading to time dilation. But time dilation is not just a theoretical concept. It has been proven in practice too. Experiments using highly accurate atomic clocks have shown that time does indeed pass at different rates depending on speed and gravity. These findings have been crucial in validating Einstein's theory and deepening our understanding of the universe. One of the most intriguing aspects of time dilation is the twin paradox. This thought experiment involves a pair of twins, one of whom makes a journey into space in a high-speed rocket and returns home to find that the other twin has aged more. This happens because from the perspective of the twin on Earth, the traveling twin was in a high-speed motion and hence experienced time dilation. The concept of time dilation extends into the realm of space travel. Astronauts aboard the International Space Station, for example, age slightly slower than people on Earth due to the effects of time dilation. This has serious implications for long-term space travel, potentially making interstellar travel a reality in the future. Time dilation is a significant factor to consider in the realm of space travel. The interstellar connection is profound. As a spaceship approaches the speed of light, time aboard would slow relative to time on Earth. This effect, fascinating as it is, could make interstellar travel a viable reality, with astronauts aging slower than their counterparts on Earth. Experimental proof of time dilation isn't just theoretical, it's been demonstrated in various studies. The lifespan of muons, for example, is significantly extended when they are moving at high speeds. Similarly, GPS satellites adjust for time dilation by using highly accurate atomic clocks, accounting for the slight difference caused by their speed and altitude. In our everyday existence, time dilation isn't just an abstract concept, but a real-life phenomenon we experience, albeit on an almost imperceptible scale. For instance, someone living at a high altitude, where gravity is slightly weaker, will experience time moving slightly faster than someone at sea level. This effect, though minuscule, is a testament to Einstein's predictions. Gravitational time dilation, another intriguing aspect, explains how gravity affects time. Time runs slower where gravity is strong. This means that a clock closer to a massive object will tick slower than a clock situated further away. This phenomenon has been confirmed through precise timekeeping experiments. The concept of time dilation extends even to the mysterious realms of black holes. As an object approaches a black hole, time for it slows down dramatically compared to an observer far away. This is due to the immense gravitational pull of the black hole, distorting time in its vicinity, a phenomenon that continues to intrigue scientists. The concept of time dilation becomes even more intriguing when we consider the impact of speed. According to Einstein's theory, as an object approaches the speed of light, time for it slows down. This means that time would virtually stand still for a light-speed traveler, underpinning the idea that faster speeds lead to slower time. When we apply time dilation to the age of the universe, we gain a cosmic perspective. The universe is approximately 13.8 billion years old, but this age is relative to an observer moving at a uniform speed. For an observer traveling at different speeds or in high gravitational fields, the age of the universe would be different due to time dilation. Behind the fascinating concept of time dilation lies a complex world of mathematics. The formulas that explain time dilation involve intricate calculations and deep understanding of physics. These equations, though challenging, are essential in proving and predicting how time varies in different scenarios. Time dilation has significantly influenced science fiction. It has given birth to compelling narratives in novels and movies, where characters travel at near-light speeds or venture near black holes, causing significant time dilation effects. The concept allows creators to explore themes of time and reality in a unique way. The philosophical implications of time dilation are profound. It challenges our perception of time as a constant, suggesting instead that it's flexible and relative. This presents fascinating philosophical questions about the nature of reality, our understanding of existence, and our place in the universe. The future of time dilation research holds immense potential. Advancements in technology and space exploration may allow us to test the boundaries of this complex phenomenon more thoroughly, unlocking new layers of understanding about our universe's structure and function. However, it's crucial to acknowledge the limitations and criticisms of time dilation. Despite the numerous experiments and observations supporting its existence, there remain unresolved questions and challenges. Some critics argue that the concept might oversimplify the complexities of time-space interactions, urging for a more nuanced approach. In conclusion, the study of time dilation significantly contributes to our understanding of the universe. It challenges our conventional perceptions of time, opening doors to fascinating theories and possibilities. As we push the frontier of knowledge, we inch closer to unraveling the profound mysteries of our cosmos.